All right, hopefully you took some time this weekend to try the practice sheet. There's some pretty useful chemistry practice problems, as well as one problem that's asking you to kind of think back to our energy unit. In the first question, it says for each chemical formula, identify how many elements and total number of atoms that are present in a single molecule of each of these compounds. What you're looking for is capital letters representing different elements. On the periodic table, those are called element symbols. There might have been a little bit of confusion for a few people right here with this, what looks like an I that is actually a lowercase l. So there's potassium represented by the capital K and chlorine represented by the uppercase C with the lowercase l for two elements. Because there's no subscripts, there is one potassium atom and one chlorine atom for a total of two atoms that would make up that molecule. When you look at iron and you look at sulfur together, there are two sulfur atoms and there is one iron atom. So there would be two total elements, iron and sulfur, but three total atoms of those two elements. You can look at the others and kind of look and look for the same thing. We have a calcium atom, a carbon atom, and three oxygen atoms. So three elements, calcium, carbon, and oxygen. And there are five total atoms that make up that molecule. Number two, I had asked you to cross out the keyword that doesn't belong and circle the one that includes the others. There might be some different answers for this, but this was my sentence, and I probably wouldn't have expected you to have something as detailed as this, but hopefully you had parts of the same type of answer I had. So I would have written that a compound contains a group of the same type of molecules. If the molecules that make up a compound chemically change, if you break them down by a chemical reaction, in other words, they can be physically separated into different elements that made up all of the molecules. These elements could then be physically separated until you reach the smallest piece of an element that would be left, and that is called an atom. Number three was a review problem. It was asking questions about potential and kinetic energy. The ball would have the most amount of potential energy at point A. It's at its highest point. And at the point that it reaches point D, all of its potential or stored up energy would have been transformed into kinetic energy. And then as it goes up the second hill, the kinetic energy will have been transformed back into potential energy. I talked to some of you about question number four, why the ball wouldn't make it over the hill at point past point G. Some of you argued, and I can see where you're coming from, that the second hill isn't quite as high as the first hill. And if that's true, there is a possibility that the ball could have gotten over point G. But if point G was as high as point A, it would have been because some energy would have been transferred to the track, most likely due to probably friction.